decided to do something not at all complicated and just invite a whole bunch of people on the stage to talk about their 97 things. So there's going to be a certain amount of coordination between the various speakers who may or may not be here. What could possibly go wrong?
Yeah.
Are we ready?
Yeah, we're ready. Although apparently I've got, this is all chained in. So apparently this is to remind me who I am. I'm him.
This is
KEVLIN
me.
HENNEY.
When I used to have red hair.
Actually, no, I've cunningly done it so you can't tell how much hair. It's a very carefully cropped image. So 97 Things Every Java Programmer Should Know was a project that we finished as coronavirus descended across the world. This is like, well, we might as well finish this project. It had started in earnest really a year before. It had been foreshadowed by a number of things. And it was really this idea, the tagline that O'Reilly sometimes uses, collective wisdom. And it is very much we've got this idea of crowdsourcing the wisdom. Any individual could probably come up with 97 things that they would recommend. But they would miss something. If you go across a group of people, you'll get a much more interesting selection and also more interesting voices. People will express things in ways that you had never come across. We're not saying that this is the only 97 things. It just happens, here's a sample.
And some things are deliberately contradictory because we understand that in industry, the answer is, it depends. So we kind of wanted to show various different viewpoints and the fact there is not necessarily one right answer to everything, and there's different approaches to different things. So 97 miscellaneous Java-ish things, even by people who aren't necessarily Java programmers. So,
because this is what Java programmers should know, and that it's not just from within, it's pretty much a cross-section.
Okay. So yes, so that was the book, which we finished 4 years ago, which, given that coronavirus meant that we had -3 years in the middle, we finished it last year.
Yes, that's right.
Totally ready to tell
Because this is the
everyone
launch event, effectively, because we planned this. We thought, that'll be fine. It'll all clear up by the end of 2020. We'll have a launch event. And here it is in 2020, plus a bit.
Plus some. Let's talk about dates later. So these are all the different topics that we talk about. Obviously, we don't expect you to be able to see that. If you have not already got the book, we will give you an opportunity to win one of 2 books. There's a QR code at the end, so give us your details, and I will randomly draw some names and then email you, and you can come and pick it up from the Gradle stand. I think that's probably the best way to do it. So you get about 20 seconds to put in your email address at the end of this talk. So those are the things, and these are all the various different artists.
They are artists. They express themselves,
Authors, these are all now published authors. And the people we have here today are Anders, Brian, Holly. I'm just doing a roll call. Are you here?
Yes.
Josh, KEVLIN, Peter, and I saw Peter. Where's he gone? Oh, he's there. And me.
You. Yeah. So just so you know some numbers of 97 things, we have 73 contributors, which is a really nice high representation there. And statistically, we knew that there would be a number of people who were here at this event. So we haven't got everybody who's potentially at this event. We realized yet last night that I missed one, but we've got enough.
Yeah.
So I'm going to
all right, so
get
now
off
it's
the
me.
stage.
Great.
It's you.
So I did 3 pieces. I did 3 pieces for 97 things, and KEVLIN liked it so much that he invited me to co-edit the thing, which was not what I had in mind, but okay. And the first piece I did was learn your IDE to reduce your cognitive load. Probably not a huge surprise to anyone who remembers that I used to work for JetBrains and do a whole bunch of stuff on the IDE. I have a video which might work, because I usually do live demos, and I thought, you know what, I'm a bit sick of losing 6 years of my life every time I do a live demo and something doesn't go right. And in particular, with the fact that we have so many people to change over, that I thought that it'd be much easier, much better, just to do a video. But I did record this myself, so that's fine. So the idea is not necessarily about learning specific keyboard shortcuts or specific tips, and if you've seen any of my presentations before, you'll probably know most of these anyway. The point about the piece in particular is that if you learn the keyboard shortcuts, if you learn your tools, specifically the IDE, but not just the IDE, it will help you to stay in the flow. Now, given my talk yesterday about developer productivity, I understand that actually developers don't spend the majority of their time writing code, and that learning a shortcut or 2 to save you seconds or milliseconds is not a huge time saving in the grand scheme of things. But it's not necessarily about saving this second. It's not necessarily about getting your hand off the mouse to save time. It's about the muscle memory. It's about learning how to embrace the tools so that you can focus on the things that you're really good at. You're trying to solve a business problem. You're not necessarily trying to figure out, where is that feature inside the IDE and how do I get to it? And I believe there's been studies done which shows that literally every time you move your move your hands off the keyboard onto the mouse, that's enough of a context switch to kind of make you forget what you were doing. So if you learn your keyboard shortcuts, if you understand the IDE, obviously my preference is for IntelliJ IDEA, but it doesn't have to be IntelliJ IDEA. That really helps you to stay in the flow of what you're doing as you're programming. Not to mention that in a language like Java, where we still have more boilerplate than some of the other languages, then using tooling to generate some of the code is quite a good way to save yourself a whole bunch of time. Now I'm giving this presentation, I realize that, 1,000 words or whatever it is on the page is not 5 minutes of content, but I do have 3 minutes of demo, which hasn't quite finished. So I was kind of hoping to talk through some of these tips, but my favorite tips in the IDE are, bog standard code completion, which comes up all the time, but live templates. I used a live template to generate a custom structure for my test method, because I like my tests to look a particular way. And I don't necessarily want the IDE to do its thing. I want to tell it what it needs to look like. And I want it to look, a JUnit 5 test to have a particular structure. So I've learned how to use live templates to generate the code the way that I want it to, so I always get it the shape that I want it in. One of my other favorite features is around refactoring. So IntelliJ IDEA, the idea, especially if you're doing TDD, but it doesn't have to be TDD, is once you have a passing test, you can use your IDE to reshape the code the way that you want it to. You can take, obviously this is a simple piece of code, but you can take code like this and you can decide, where do I want that variable? Do I want it inside, in this case, the getter? Do I want it as a field? Do I want to initialize it in the constructor? Or do I want to do something different? And the IDE will allow us to make those changes and see what it feels like without breaking the code, without making the compiler have a freak out. So you can use the IDE to reshape, rework, remove your code, and see what works best for you. Again, the answer is it depends. Is a constant better than having it declared in the constructor? It depends a bit on your team and what your preferences are. So you can use the IDE to reshape the code in a way which is useful for you and your team without breaking the code and with your tests still compiling. So without further ado, let's move on to the next 97 thing.
Not 97 thinks. I don't know how that works.
Oh, I'll do that. You can talk.
Oh, okay, cool. Right, okay. So actually, curiously enough, we just mentioned that we've been talking about tests. So let's talk about programming with guts. So this is one of my pieces. You will see, by the way, that some pieces we've associated, they have a Medium link, and some of the contributions were collected from Medium, and so those are still available. So programming with guts. So you're writing unit tests, yeah? Yeah. Don't look guilty if you're not. We're not out to challenge you on this one. Just assume the answer is yes. That's great. But the question is, are they any good? Do you have guts? And where's this term come from? The term comes from Alistair Cockburn originally. Very many people say TDD when they really mean, I have good unit tests. I have guts. And we're going to make guts distinct from TDD. TDD is a way of doing something. It's a workflow. Guts is a thing that you leave, that is results from it. It's a what. It's what the next person along is going to see. They don't actually care whether you TDD'd it or not. They care, do I understand it? They care for good unit tests. So that's the thing. Have we left people with technical debt in the test base, or are they going to thank us? And remember, they might be you. So we have to get concrete. What do I mean by good? So we are, 2024. This is the 50th anniversary of the stack as an abstract data type. Barbara Liskov, Programming with Abstract Data Types, 1974. That's the first time that anybody decided, you know what, this is a good candidate. And I feel no reason to break with history, and I'm going to honor Barbara Liskov by having a stack. It's got depth, it's got a top, it's got push, it's got pop. It's a pure pop, it's a strict pop. We're having none of this peak nonsense. We're actually going to use the proper vocabulary. Okay, not this stuff that Sun threw in, which is, misunderstood. Read the original paper, guys. So this is how a lot of people will then go about testing it. In fact, there are even additional tools which will code generate this for you. In other words, do the wrong thing. Brilliant, I've got code generation to do the wrong thing. What we're going to do is we're going to take each method and we're going to test it. How do you test a method? It's not actually possible. Because in order to test a method, I have to have a thing to test it on, then I have to have a thing that I want to say about it. That normally results in a bunch of methods being called. It's a system of usage we're testing. We're not testing individual methods. So this is not very helpful. So also, by the way, the word test doesn't help either. Because, I mean, honestly, if people can't figure out it's a test with @test all over it, they are beyond your help. It's not your problem. So sometimes people try and kind of wheedle away from this, and they come up with some fantastic stuff, like constructor is correct, depth is okay, top is working, push works, pop works as expected, my favorite. I saw that one in a code base last year. Works as expected. I have no idea what you're expecting. These are just more words, and yes, we're working in Java, and people like to add words. Less. More meaning. Sometimes people work around it with the can workaround. Again, it's a workaround. That's also a test file. Can be constructed, has depth, has top, can be pushed, can be popped. But you know the thing about stacks? They can't always be popped, and they don't always have a top. Brilliant. Sometimes has a top, can sometimes be popped. Wow, you are really communicating at this point. Not. A new stack is empty. An empty stack, oh, okay. You've actually decided to describe the thing in front of you. Awesome. Okay, an empty stack throws when query for its top, an empty stack. This is fantastic. So this is great. Yeah, a bit of screen real estate. Thank you very much. So now I've got these words. Now, as you may notice, this borders on unreadable because camel case does not scale above about 30 letters. Okay, so therefore I'm going to, you can throw me out the building. I am going to break with that because these are not ordinary method names. These method names are test names. These test names are written once. You don't refer to them anywhere else in the code. They are not verb phrases or noun phrases. They are full sentences. And there's also, in JUnit 5, replace underscores. Oh, nice. So that means I get this in my output. That's nice. But I'm actually going to recognize that some of those names are long. In fact, they're not arbitrarily long. They are systematically long. They have repeating parts. What do we do with repetition? Well, if you're an enterprise programmer, you double down on it. Copy and paste. But not the folks here. We extract it. We recognize commonality for what it is. We try to communicate that to the reader. So I've got a state model here. I've got new stack. I've got empty stack. I've got non-empty stack. This is fantastic. I've now actually got a structure. So this is my spec. And I'm going to call it spec. So I'm going to use nested here to show and communicate that commonality. Well, I'm providing you with a model. I'm taking a model that I have, and I'm trying to transfer it into your head. It's one of the hardest things that we do as humans, but it's also one of the most successful. So, that would be the time's up.
It is time up.
I hope that's been useful. You're off to visit some, redo your tests. Okay, see you later. Right.
I'll do that. You do that.
Actually, I'll do that. You've got that.
Oh, you've only got one slide. Yes, it is. Try it now.
It's on now. Hi all, I'm Anders. I wrote this first chapter of this book a while back. I couldn't really recall what I'd written about, so I had to pull the book out of the shelf and reread it for this presentation. And I also did this beautiful slide on the flight over from Oslo. No other slides than that. So I told KEVLIN I would do this entirely naked, not literally, but without slides. So my chapter is called All You Need Is Java. And I always hear this little trumpet in my head when I say that. It's a story that starts out with Microsoft. When Microsoft, back in 2008, were creating a new revision of Visual Studio, they defined some personas, developer personas, that Microsoft Research had come up with. They were Mort, who was the everyday programmer who just wanted to get the job done, learning on the job while figuring things out. Then you had Elvis, who was sort of the creative programmer who wanted to build solutions for the ages. And finally, you had Einstein, who would like to invent great things. And over at the Java side of the religious divide of programming languages, we were in the age of frameworks, and more or less all of us were Einsteins trying to build great frameworks to build stuff with. And there weren't really any Java programmers around. Everyone was either a Spring programmer or you wrote EJBs. You were familiar with frameworks, basically. And just about everyone had forgotten that Java was a language that had capabilities of its own. And my chapter is about rediscovering what Java can do. Because whenever I was starting a new project, I would pull out Maven and start adding the dependencies I thought I would need. These days, I would probably use Gradle.
Yes.
Sponsored session.
Yeah. So think about things like, if you want to do some HTTP requests, you would probably pull out something like OK HTTP, but you could always use the built-in HTTP request client in Java. It does not have as sexy an interface as OK HTTP, but it does get the job done. You can work with files using the Neo frameworks, and Java even comes with a full-fledged HTTP server in there in the base class library. And all of these things are there for you to use. And when we are building things like serverless functions, deploying pure Java code makes things a whole lot easier. And another thing is that these days we seldom program on our own. We probably use something like GitHub's Copilot. And you know what? GitHub Copilot knows the Java base class libraries. So all the things that you have forgotten about how to write pure Java code, the Copilot knows and can help you along. Now, once in a while, you probably need something more advanced than you get in the Java frameworks, and that's fine. That's the time when you pull in a library. But don't just use those libraries out of habit. Use them because there is a proper need for using them. Be it Morts. Morts are happy programmers that do not need to prove to themselves that they are Einsteins because they know how to get the job done. All you need is Java. Thank you.
To Holly. Where's the... it's there. Cool.
I'm going to talk about garbage collection. So I'm not going to do the talk naked, because I don't think anybody, wants to talk about garbage collection without visual assistance. So I wrote 2 pieces for 97 Things. One is about garbage collection, and the other is about how Java should be fun. These 2 pieces are actually more connected than it seems on the surface. But let's start by talking about garbage collection, because I think a lot of us, we're Java developers, we love a lot of things about Java, but the garbage collection is maybe not one of the things that we say, oh, a garbage collection, I really love garbage collection. We tend to think of garbage collection as a hindrance of, my program would work so well if only it wasn't for that garbage collection. But actually, garbage collection does a lot for us. And if you try and do memory management without garbage collection, you're going to have a lot of problems. The first problem is that it is hard. And what that means is that as a developer, even if you're a really clever developer, you become a slow, clever developer. The second problem is that you're probably not clever enough because nobody is clever enough. So if you try and do development without garbage collection, it is dangerous. It is leaky. It is crashy. And of course, this is why Rust is now replacing C, because Rust has reference counting garbage collection. And the last thing about garbage collection is that most of us think, well, I'm OK with garbage collection in order to get those benefits. But it slows my program down. It does not slow your program down as much as you think. It may even be speeding your program up. And so what a lot of people do, and you can find a lot of books that will say, in order to optimize your Java, try and reduce your overall pause times. This is really, really bad advice. Do not do this. Because what garbage collection does for us is automated memory management. And programs do a lot of things with memory, or rather they do 3 things with memory. They access memory, they allocate memory, and they free memory. And when you think about the impact of garbage collection on your program, you need to think holistically. You need to think about all 3 of these things, because garbage collection influences all 3 of these things. So let's start by looking at memory access. It used to be that CPUs were slow and memory was fast. Now it is the opposite. Memory is glacially slow compared to CPUs. Moore's law has not applied to memory. So you don't ever want your program to be reading things out of RAM. You want it to be reading things out of the caches. Caches are expensive, and so we have varying degrees of caches. The faster the cache, the less cache you have. So you can see that these objects over here didn't make it into the cache. And in the end, to get to the level 3 cache, which is where you want your stuff to be, only this object made it in. What if I rearranged my heap a little bit? What if I moved more of my objects closer together? What that means then is that when I read from the RAM into my caches, everything gets into the level 1 cache, and quite a lot of it gets into the higher level of cache. That is cool. And this is what garbage collection can do for us. Programs spend most of their time reading and writing memory. Garbage collection can make that faster. And if you want to sound clever, you can call this object locality, and then people will assume you know what you're talking about. The other thing that programs spend a lot of time doing is allocating memory. So to allocate memory, you have to go through and you have to find a bit of heap that's big enough. And you look through a free list to do that. It can be slow. What garbage collection can do for you is rearrange your objects so that they're closer together, which means that allocating memory is really fast. And then, of course, the last thing that garbage collection does that we all know about is recover memory. There's various ways of doing this. A classic one of doing this is what's called a mark sweep collection. So if I have these little guys over on the right, they're no longer referenced, which is fine, until I want to allocate something, and it's too big. That is not going to fit anywhere, so I need to do a collection. So what I'd have to do is I look at everything that is used, I trace what's used, and then I go through, and if it is used, I keep it. If it is not used, I get rid of it from the heap. And then once I've done that, I can do my allocation. The other thing I can do is I can do a copying collection. With a copying collection, 2 seconds, I promise. I keep a little bit of heap held back, and then I only need to look at things are live, copy them there, and then I just blow away the rest of the heap. So that gives me really, really fast allocation, and garbage is free to collect. So there's various ways of doing things. It depends what is the right thing to do, but when you think about your GC, you probably don't need to touch anything. If you do touch things, think holistically rather than just trying to shorten your time in GC, because that might make your program slow, which is not what you were trying to achieve. Thank you.
Yeah.
Now, we're going to do some trickery. We're going to change machines.
Quick changeover.
Yeah, I've been watching Formula One recently, and this is kind of like, this is a pit stop. Yeah, see that? Look at the efficiency here.
Good.
Time.
Oh.
Yeah. Good stuff.
Do you want me to hold the mic in front of you? Because you're going to need to...
Yeah, I think maybe it'll... sorry.
Oh, my God.
Hi, good afternoon, everybody. Good stuff. I wrote a thing for 97 Things called, it's all about production. I love production. You should love production. You should go as early and often as possible. I say this to people all the time. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. That said, how do you get there, right? You gotta streamline the effort as much as possible, embrace convention over configuration, embrace frameworks like Spring Boot and continuous delivery pipelines. Remember, friends, this stuff is free, right? There's no reason not to use this stuff if you just put a little effort into it. This removes boilerplate and allows you to both stand up new services quickly and, once stood up, focus on building stuff that you like. You can, of course, have a starter project. So, for example, this code that we are looking at here today, this is on github.com, and you can use it as a template, but that will rot eventually. This will become obsolete. And so what you want is really to make it easy to stand up a new project that is in compliance with modern norms. And so, of course, there are things like start.spring.io. And this is actually an open source project, so you can fork it yourself if you like, and create your own start.spring.io that has the ability to incept new projects with your project's governance and guidelines and mandatory libraries all configured. But of course, maybe you don't want to use the service. It's actually a REST API, and if you're using IntelliJ, which Trisha and I both adore, then you can actually, this curl HTTPS. This is actually an API that is being used to feed the wizard that is inside of file new project inside of IntelliJ, right? And likewise, those other IDEs, those other text editors.
There are other IDEs.
We won't mention those. They know who they are. So yeah, I love start.spring.io. It is my second favorite place on the internet after production. Obviously, production is my first favorite, right? But it's good stuff. And by the way, you can fork start.spring.io. The importance of all this is that nobody wants to feel like they're doing drudgery. It's bad for morale. People who are happier do a better job. They feel invested in their work. And this, of course, reminds me of one of my favorite quotes. If you want to build a ship, don't drum up people to collect wood and don't assign them tasks and work, but rather teach them to yearn for the vast and endless seas. That's Antoine Saint-Exupéry. And frankly, the vast and endless seas, production in this case, can be very beautiful, but the waters can be a little choppy. So you need to design your code to survive there. So once you've got a new project, there are heaps of amazing libraries that you can use to handle the volatility of a production environment. Things like retries, things like failure management, and so on. So I've got an example here in the Git repository. This is a service registry. It's good for client-side load balancing. So you go here, and you can see I've got like a phone book with all my services there, right? One service and another. And one service, production, is going to call the other backend service. By the way, you can see this is Java. We don't waste it. This is not PHP. We don't write extra code for no reason. I wanted a service registry. I typed in that line of code there. I got a service registry. What did you do today, right? So I've got my service registry. And then I wanted an actual service. This is a back-end flaky service. It's randomly going to fail. And I've got an actual client application that's using an HTTP client, and I'm making calls to that HTTP client here. If it goes right, great. If not, I have a fallback because I have a circuit breaker. So I can go here now to the browser, make this call, and you can see it says, oops, hello from port 5469. I'm load balancing as well, all in the client call that I just did, right? Super, super intuitive. Okay, so good. So now we've got an application. What about scale? Well, of course, Java has virtual threads now, right? It's an amazing time to be alive. So you go to application.properties, you go to production, and you can see I've got this one little property here, virtual threads, free scale. That's a huge deal. Right, let's get to production. We want this to be as fast and efficient and RAM efficient as possible. Go to start.spring.io. You can see there's lots of ways to get more efficient programs, but it's worth mentioning Java is already very efficient. Did you see this amazing blog from 2018 BC, before the COVID pandemic? This blog looks at the top 5 most energy efficient languages: C, Rust, C++, Ada, and then Java, right? Disgusting, that one. Moving on, so it's already RAM efficient and it's already very fast. You saw Gunnar Morling's 1BRC where he parses Java, they have a Java program that parses 13 gigs of text data, and the fastest entry is 1.5 seconds. So don't let anybody tell you Java isn't worthy of production. That said, most of these top entries use GraalVM. Okay, so we'll do that too, right? So I've got over here, I've got a GraalVM application. This service that we're looking at is actually GraalVM, so go ahead and do that again. Boom, up and running in 1/10 of a second. And the RAM is about 120 megs of RAM, right? So we've got an application that's worthy of production. It's fast, it's scalable, good stuff. So what about you? What about right now? Are you ready for production? Do you yearn for the vast and endless seas? Thank you so much, everybody.
Brilliant.
That's for you.
For those of you watching the video recording, you can go back to 1.5 speed now.
Do you want that?
Hi. So I wrote a contribution for 97 Things called Refactor Boolean Values to Enumerations. That's it. That's the advice. Here's why. So Boolean values optimize for physical computer things, a single bit of storage. You know, Java language takes the convention of calling these two values, true and false. But what does true even mean? This is advice for junior programmers, which is to learn the idiomatic style in your own language. So, sure, I mean, you could write C code in any language, famously. Please don't do that. So in Java, writing idiomatic style means, among other things, using enumerations, using enumerated types. So enumerated types give you a way to write easier to read, easier, more maintainable code because you get to name the values instead of having those values look like true or false. Because here's the thing, you know, you wouldn't write magic numbers in your code, but we see magic booleans everywhere. You know, a value, literal true, but what does that mean? That's even worse than a magic number. At least if it said 37, you might recognize what you might have 37 of. Or 97, you know, to pick a random number. So use enumerations, name the values, and that's fun because you get more things to name, which is awkward. But so I had to write a second contribution. The second chapter I wrote is called Get Better at Naming Things, which is famously fun. So if you find programming too easy, this is your next challenge. This is advice for more experienced programmers. So you need to stop writing code that merely compiles and write code that people will be able to read and understand. As KEVLIN pointed out, people includes future you. So future you will not know what you meant when you named that variable foo. Come up with better names. You know, because the compiler doesn't care. So I'm still sad that a spelling mistake in a variable name is not a hard compilation error in any programming language, but it should be in all of them. Meanwhile, we're just going to have to come up with good names and use some tooling to make that work. How do you do this? So the advice, adopt naming guidelines, expand your vocabulary. I don't know, maybe read books or something. But crucially, use domain vocabulary, you know, embrace domain-driven design, discover the ubiquitous vocabulary for your domain, and use that. Don't use meaningless names like manager because, I mean, who knows what a manager does? And sometimes break the rules, like KEVLIN's test names, you know, step outside the language a bit. And because you have to do things in freeze, I wrote a third one, and the third one is a bit spicy. Write comments. This is a bit awkward because you're programmers and you don't want to, but it's worse than that because even if you have perfect naming because you mastered that, even if you've mastered good unit tests because you were paying attention earlier, self-documenting code is still wishful thinking. I'm sorry, it just isn't, because there are things that the code cannot explain. So the code cannot say why it exists. Here's the advice for advanced programmers. Go beyond the Java language constraints, escape from Java, and just write things in English. Write things in clear English to explain what you cannot write in Java. I'm sure you don't accept bad comments. You probably deleted them all at some point in your career. Now is the time to go beyond that and work out what are the good comments you should put back. Now there's a great hack for this, but I don't have time, so you'll have to read the chapter. Buy the book or find it on the link over there. But crucially, what I want you to do is to document the code's business value. Find the code's true meaning in its purpose. Like in life, you might find meaning you might find purpose. Give that to your code as well. Use this understanding to work better with stakeholders who are not programmers. You know, understand the idea that there might be meaning beyond what the code says. Above all, write code with meaning. Thank you.
Hi. Ooh, that one's hard. Yes. Take good care of your dependencies. Question to y'all. Who writes Java code without any dependencies? Yeah, that's wishful thinking indeed. Like, if this is your application, your binary that goes into production, how much of this is the code you wrote? Probably this. And we take good care of that code. Who does code reviews? Okay, the rest does pair programming, great. So we take good care of that bit in the middle. But how about the rest of it? Do you have some process on how do you care about these dependencies? Because the majority, 90% of the code that you put into production is not yours. You just borrowed it from the internet. And nowadays, the 10% you wrote there is probably done by Copilot anyway. Anyway, a couple of years ago, around the time that we created this book, I wrote this tweet. I misused Spring Boot to create a 4-line Hello World application. Just an endpoint that says hello world. I packaged it as a jar, unpackaged it, and looked at the amount of lines of code that my team potentially has to maintain. It wasn't 4, it was over 500,000. Meaning that if you use, first of all, use the right dependencies, don't use Spring Boot for a hello world application, but if you use a dependency, make sure that you know what you bring in. Because all these things are part of your class path and can be loaded into memory, which potentially comes with security issues. My first job was at a bank in the Netherlands, and this was their Maven file of some big monolithic application. This was line 977 to 1023 dependencies. I was looking at them and I found 3 XML marshallers, which was weird because Java already has XML marshallers in it. And that's things that we see. We build on top of other things, and we bring in new dependencies because who knows what this dependency does. I'm not aware of it, but I need to get this thing done, so I bring in a new dependency. But are these dependencies up to date? Are they actually used? What we know is that they're part of your class path, and they can be loaded into memory and be part of an attack chain. So, what should we do? First of all, scan your application and be aware that the dependencies that you have in, bring in other dependencies, etc., and there might be vulnerabilities in there. So, that's one thing you should know. Scan it and be sure that there aren't, or at least if there are, you're comfortable with what the attack vector is. But next to that, make sure that you update them as well. I mean, if you use Maven or Gradle, it doesn't matter. There are things in your builder, in your package manager, that can look for you if there are new updates of a certain dependencies. You don't have to just manually scroll that and look on the internet. There are things there, so you can automate this. Also, there are other tools to automate this. For instance, to see if a package has a security vulnerability, or if there's already an update, you can chime that in, for instance, in your GitHub repository, and it automatically creates pull requests. And obviously, this is a tool that my company uses, but there are more tools like, I don't know, the Pendabot or whatever, or you can do it yourself in your build pipeline. Thing is, there is no need to do this manually. But think about it. If there is a security vulnerability, at that point, the maintainers will try to fix it, but they fix the latest version. What about if you are 5 major versions behind? That might break API, which means that you need to bring maybe other things in. We need to update our Spring Boot application. We need to get a new version of Hibernate. I don't know, but it breaks all sorts of things, and you get a domino effect. So the point is, we all know where we were at December 10th, 2021, right? Log4Shell. The problem was not that there was a problem. The problem was that people couldn't fix it because they were outdated. So make sure your dependencies are up to date, and the delta between the newest version and your version in your application is small. Because if you need to fix it because of a major vulnerability, be aware that you can. So make sure that just like your home, just like your car, just like everything, your application needs maintenance. And that's not just your code, but it's also the code you implicitly inherit from the internet because of your dependencies. Thank you so much.
Oh yeah, you can do that. Right, so we have some time left for us to do more, so I'm going to do one of KEVLIN's, which is actually quite fun because I wanted to talk about dates, but KEVLIN did a way better job of it, so I just get to talk about his thing as if it was my idea. My favorite thing about this piece is the way that KEVLIN paraphrased Pride and Prejudice, because, you know, it's one of the best opening lines in a book. It is a truth universally acknowledged that a single programmer in possession of the belief they understand dates and times must be in want of a code review. And I can attest to this. When I used to work for MongoDB, I used to do a bunch of time, I had to do my time on Stack Overflow answering questions. And one of the things I used to do is look for Java questions to answer. Not really surprisingly in hindsight, a lot of the questions are around dates. As programmers, we just think we understand dates because we live in time. And we know that tomorrow is the, whatever it is, 10th. And we know that time moves forward. And we know there's things like time zones, probably. So we think we understand it, but we don't understand it. Date is way more complicated than you think it is. In particular, I have found in the UK, we can actually struggle with it more than other places because A, we have one time zone, and B, that time zone is UTC for 6 months of the year. And when I worked at LMAX here in London, we had a great team, very smart, some of the smartest people I've ever worked with. We had lots of acceptance tests, we had good practices, TDD, good naming, we didn't have comments. And we did all the right things, but every year, when summertime turned on or off, a dozen tests broke because we made assumptions about time zone or lack of time zone. It's very easy to get dates wrong. The examples that KEVLIN put in the book is that date, java.util.date, is anyone still using java.util.date? I'm not, yeah. I'm not surprised. I mean, it was deprecated, what, like 20 years ago, I think, when Calendar came in. But it's much easier to use than Calendar, and not all of us are using new Java Time or whatever it is, which came in about 8 years ago now. I don't know what happened to the last few years. But java.util.date is not a date. I'm going to go back. It's not a date because it's a date and a time. It's not just the date. So that's really confusing. GetDate does not get the date. It gets, I should have made notes of this. Oh, I did. It gets the day of the month. I'm like, okay. And getDay, does it get the day of the week, the day of the month, or the day of the year? Because it's not clearly said. So not only is date difficult and time difficult, it's made more difficult by poor naming choices. So, you know, if you have a date, you kind of expect it to be a date, and if you call getDate, you kind of expect it to get the date. But there's a lot of ambiguity there. And so when it comes to any programming, as we've already seen, the naming is very, very important. But for date and time, possibly more so. And the other thing that I liked, oh, right, so the example was that Apollo 11 landed on the moon at 17 minutes past 8 on the 20th of July, 1969. But if you put that into a date object, and I tested this, I did it this morning, and I couldn't remember how date worked, getTime returns a negative number, which is millis from 1970. GetDate returns 20, that kind of makes sense, because it's the 20th of July. GetMonth returns 6, because July is the 6th month of the year. It's not, it's the 7th, because month is indexed by 0. Great. Why is day not indexed by 0? Well, because it's the 20th, isn't it? And getYear returns 69, because apparently it's too expensive to store 1969. Like, I mean, were they intentionally trying to make our lives more difficult? I'm sorry to the Sun programmers. I'm sure you were doing the right things at the time, but honestly, things have been very difficult. So, dates and time are difficult. Every time you come across anything to do with time, have a think, and a second think, and a third think about whether you're doing the right thing. And also, do not use java.util.date. Thank you very much.
Okay, so in the interest of symmetry, I'm going to do one of Trisha's, which I quite enjoy. The whole thing here, technical interviewing is a skill worth developing. Everything you need to know is there. Because we're outlining the fact that it is actually a separate skill. It's a skill on both sides of the table. To the point, Trisha says, we are horrible at interviewing. This I know for a fact. My wife used to be in HR and was kind of shocked by the way that we didn't do things in this industry. And there is this challenge. We often think, oh, my technical knowledge, that's what I need to, that's what I'm going to be evaluated on when I go for this interview. It's my technical skills. It's my portfolio of things that I have developed. That's what it is. Turns out that people can't just touch that and know it. And what's also interesting is that they often don't ask you to actually demonstrate the skill that you have actually exercised. So can you use frameworks X, Y, and Z? Yes. Okay, it's good. Where's the evidence? Where's the proof? We don't do that. So there is this whole thing that we need to understand. If you don't get a role that you really wanted, sometimes it kind of reflects back on you initially. You think, well, that's a deficiency in me. I don't know enough. I lacked the knowledge. I lacked the skill. That last one is half right. It's that interviewing is a separate skill, independent in many ways from the technical skills that you so obviously value. So there is this idea: how are you going to get through the interview? It's this idea that the interview is not an evaluation of you. It's simply a step on the path, and you need to understand what's involved in that step. It's like formatting a good CV. A CV is not to sell you, it's to get the interview. The interview is not actually your totality, it's something. And what is the something? Well, there's a number of things that people will normally ask. And there's a standard set of Java questions. You can kind of Google around. TRISHA identified 3 areas that you might want to kind of dig into a little more. Multi-threading, that's always an interesting one, because that also allows you to interview the other company implicitly. If they show you a piece of code and say, yeah, we've got a bunch of threads here, a whole load of mutable state, and piles of synchronized blocks, help. You know that you're solving their problems. You know that this might be representative of their code. If this kind of thing if you like this kind of puzzle-based approach, this might be the job for you. But if they're asking you that question, just back away really slowly. But you do need to have a good working model and to know what's there. To know that raw threads are there, but they are kind of like the lowest level. Synchronized. The idea that every object can be synchronized. That was such a bad idea. It was a bad idea in 1995. It continues to be a bad idea, but one that can't be deprecated. So you have to know something about it. But you also want to know that those are the raw materials. Above that, we have parallel streams. We have fork join possibilities. And also, there is the very Zen state of saying, you know what? If I make my objects immutable, if I restrict my mutability, threading does not matter. I'm at one with the universe. You can throw any kind of scheduler at me, and I'm just working. There are also other aspects that you might want to care about, or are forced to care about. Does this code compile? What's wrong with this? And apparently, IDEs. Is there any particular IDE that you had in mind when you were writing that?
Nothing.
We'll tell you this stuff. So you're sitting there going, well, actually, I've already got the support of my environment. Why do I need to know whether this piece of code compiles? It's more a case that you might want to help somebody. Think of it the other way around. You might want to help somebody. And they say, I don't understand why this code isn't compiling. And they don't understand maybe the message that's given to them. If you have a system of understanding in your head, that's going to make it a lot easier. So, yeah, you do have to know something about that. You don't have to know everything, but there is something that you would like to be able to know. Think of it from your point of view as this is not an interview question, but more as a case of like, yeah, some of this stuff is worth knowing because I can then pass it on to others. Then we have the whole data structures question. How much of this stuff do we need to know? How much has been inherited from C-based interviews? Well, know the data structures that are available to you. Know their costs. Know the ones that are in the standard that exist in Java util. I find a lot of developers, they go, yeah, I know those. Yeah, okay, so what do you use? Array list. So understand the way that you're going to be asked. This is a separate skill. It's worth developing because it may allow you to get to the technical stuff that you really wanted to concentrate on. Thank you.
we have approximately 30 seconds for questions. If you do want to win a copy of the book, go to here. I hope it's the right QR code. I've created like 5 this conference. Fill in your email address, and I will do the draw in an hour, probably. And then whoever wins, I'll email them, and they can come to the Gradle stand. Questions?
Yeah, we could probably, yeah, we're going to coffee, so anybody have any questions? Either yes? It feels like a century ago or last year. So like 4 years, yeah.
So would we add anything new 4 years later? I think one of the things we try to do, technical books are tricky because they do date, but what we've tried to do is get stuff which is not so dateable. So, I mean, there's things in there which are technical, like code examples, like some stream stuff. The garbage collection stuff is still valid, even though we have lots of different new garbage collectors. Stuff about threading and things is still valid, even though we've got lightweight threads and Loom and so forth. So there are things, I'm sure there's things we would add, but I don't think there's anything which has aged badly over the last 4 years.
I think it's more a case of, we could turn it around, is what, at this point, what different things would people give to us? Because it's that, you know, we're drawing from what people are offering. And we did make a choice with some things. Oh, this is really good, but it's got a shelf life that's going to expire really quickly. So yeah, it's the timeless nature. Time for another question as people start vacating. Yes. Oh, the cache ordering was inverted. So that's one you might want to have a chat with Holly. And yeah, I know there was no L4 cache. I mean, where was that?